All right, so now we're getting into inequalities, which I've mentioned over the past couple of videos. Understand everything we have been doing in the past week to get to this point. Now, inequalities is a little bit on the difficult side, only because it's not like anything we've ever seen before up to 6th grade. Well, hopefully by this time, since we did it before Christmas and right after Christmas, it's not going to be difficult. It's just going to be a reminder of what we've done. Now, this video might be a little bit longer because I'm reviewing several different things. Some things that are little things that need to take a lot of review, but some things are more in depth on what we need to review. But it's putting a lot of the things we've talked about recently all together. The first, inequalities. Well, what exactly does that mean? Well, as I told you the first time when I taught it, inequalities means exactly what it sounds like. It means that I have an answer that can be any quality in a comparison. Could be greater than, less than, equal to, we have to see. So we end up with all sorts of different types of setups on what inequalities are. We're going to have to be able to identify them. We're going to have to be able to write them. We're going to have to be able to solve for them. And then the next video is being able to solve and graph them. So on this one, we begin with comparing. Greater than, less than, or equal to. Now, which is that? Is that greater than or less than? Now, I want to be honest with you. I don't care if you know or not. This means less than. But what I want you to understand is what it means. We've talked about it several different times, and some of you still are not listening to what I'm saying. If I look at the point of the arrow, I know that my arrow will always point to the smallest number. So if this is the smaller number, then this side has to be bigger. In the same way, if I have the opposite one pointing the opposite direction, then the arrow is going to be pointing once again to the smaller number. The arrow always points to the smaller number. So writing them down backwards should never be a problem, because if that's smaller, I know that has to be bigger. Well, this is where we started giving these weird ones with lines underneath them. Not a difficult concept, right, to remember? Well, this just means that this is either smaller or it could be equal to, because this is half of an equal sign. That's all that line means. Therefore, this side still has to be bigger. And if it's pointing to the right with the underline, then that's just half the equal sign. So this side either has to be equal to or it has to be smaller. And therefore, this side has to be bigger. So let's apply those to what we're talking about. This says, to determine whether the given value of the variable is a solution of the inequality. Some big fancy words. Variable, once again, it just means a letter. Any of your ABCs that are going to be in a math problem, that's your variable. Don't make it difficult. A solution, it just means can it be an answer? If it can't be an answer, then it's wrong, and that would be not a solution. If it can be an answer, then solution would be your answers. And an inequality means that I have these symbols, and it can be anything that would fit in and make this statement true. So we're given the inequality if k is less than, because the arrow is pointing to it, 7. If I plug the 5 into that formula, is 5 less than 7? Yeah, it sure is. So I know that's a solution. Now here's the idea of the inequality. There are an infinite number of numbers that can be on this side. It cannot be 7 because it doesn't say equal to, but it could be 6 and all the way back to negative trillion, billion, zillion, quadrillion, whatever you have. So this is an endless number that it could be possible answers. That's why it's inequality that is indeed less than 7. All right, so let's plug it in here so now that we understand inequalities. 5z is greater than or equal to, because the arrow is pointing in the opposite way, 12. Well, this says z is 12. If I plug that in, is 12 greater than or equal to 12? Yeah, sure is. So I know that's a solution as well. Now, here's where I want to take a moment and look at something. What if I didn't have that equal sign? If all I had was 12 is greater than 12, is that a true statement? That's not a true statement. That's where I'd put not a solution as an answer, okay? Or, as we did on the previous assignments, we put NAS, which means not a solution. And I accept that as well. All right, so what about these? These are a little different, but I'm just going to do the same type of thing. Determine whether y is equal to 3.5 and y is equal to 0 are solutions of these inequalities. So now I'm going to have two answers for each of these. If I plug in 3.5 on where the y is 3.5 less than or equal to 3? No, it's not. That's not a solution. Well, now I'm going to do the 0. If y is, or 0 is less than or equal to 3, yeah, it's less than or equal to 3, it's less than. So that one is a solution. Two possible choices, just write it out correctly and then have your answer. Now I'm going to use these two once again, but I'm going to plug them in here. Is 3.5 greater than 3.25? Well, that one gets a little tricky sometimes, and some of you see it real quick and some of you don't. Okay? Some of you may look at the 0.5 and think, well, 0.5 is smaller than 0.25. That's not the case, and that's not how we compare. Remember, when I have decimals and I'm comparing decimals, I have to have the same number of decimal spaces so I can really see what I'm using. This has 2 decimal spaces, so this needs 2 decimal spaces. And then when I look at the decimals, I see that 50 is greater than 25. This is a true statement. It is a solution. Well, what about the 0? Is 0 greater than 3.25? No, it's not. That is not a solution. Moving on. Give 2 solutions of the inequality. Now, here's where, just stop and think for a moment. Okay? You have, once again, an infinite number of possible answers that you can put down on your paper, as long as it's a true statement. Okay? Just make sure that it's greater than 4. So all I've done is I'm going to give the next 2 possible answers. You don't have to have the same answers, but you do have to have true and proper answers. It has to be greater than 4 because the arrow is pointing to the 4. 4 has to be the smallest number. So my next possible answer that I could have is a 5. My next possible answer after that, whole number wise, would be a 6. I could put 5.17 if I wanted to, because that is still larger than 4. All right, so on this one I have P. It has to be less than or equal to. So my next 2 possible answers, and you don't have to have these as long as you have true answers, is going to be, well, it could be 3, because it's equal to, so that's a possibility. Or if I go down 1, it would be 2. Any negative number, any number smaller than 2 is going to work, as long as it's a proper answer. So then I have V, and this has it pointing away from the V, so I know V is the largest one, greater than or equal to 9. So my next 2 possible answers are, well, it could be 9, because it says or equal to, and then it could be 10, my next counting number. I don't care if you have 9 or 10, as long as you have correct answers. They have to be greater than 9 or equal to 9. Then we're going to write inequalities. We're going to read what it says, and we're going to come up with the inequalities in the way it should be written. So we have to truly think about the way it's worded to write it correctly. The distance D, so they give us our variable, Mr. Chen drove, was no more than 65 miles. Well, if they use the words no more, so it can't be greater than, could it be equal to? Yeah, it could be equal to. So I know D has to be no more than 65, but it could be equal to 65 because it's no more than 65. So 65 is my largest number. So D is going to be less than or equal to 65. That's my inequality, and that is my answer. The amount of juice C in the punch is more than 3 cups. All right, so I have more than, so I know it has to be a greater than. Greater than what? Greater than 3 cups, and I'm using a C. So I know greater than, so the C has to be on this side. C is greater than 3 cups. Can't be equal to 3 cups, can't be less than 3 cups, so I have to have more than 3 cups in it. That's my inequality. That's my answer. The age of Maya's sister is less than 8 years. So I have A for age. 8 is a number, and I know that the A has to be less than that number. So I'm going to point to the A, right? And therefore that has to be smaller than what number? Well, smaller than 8. So notice I have a label, and I forgot that label. Okay. But A is less than 8 years. All right, the last one over here. The temperature T was at least 30 degrees Fahrenheit. So if it is at least 30 degrees Fahrenheit, could it be equal to 30 degrees Fahrenheit? Yeah, it could be equal to 30 degrees Fahrenheit. But could it be below it? No, because it's at least 30. That's as cold as it got. So I know that my temperature is greater than, or it could be equal to, 30 degrees Fahrenheit. All right, so now we get into the last one. So now I have these weird inequalities where there's math suddenly applied. Well, this is taking our algebra steps that we've done and our integer work that we did on the previous lesson and mixing it all together to figure out what my n is greater or equal to, what my r is greater than. So we have to go step by step. And a reminder, what I'm looking for is to get my variable by itself. So generally, I will box in my variable, circle my variable, do something to remind myself this is what I'm looking for. And then my math has to be done with everything else. My first math step that I do has to be with the constant, with the number that is not connected to my variable. So I have a -3 out here all by itself. All right, so that's where I have to start. Well, if this is -3, taking away 3, then I have to get rid of it. So if you think back to what we said 2 videos ago, we're going to do the opposite function on the opposite side. Remember these steps. These steps will be in your math for the next 3 years of school, possibly 4 or 5, depending on what classes you take. And we did this in chemistry when I was in high school. I did this in college. So this really does work, and it will be able to be applied in multiple situations. If I do the opposite function on the opposite side, I can do these inequalities. So I have a -3, so the opposite of -3 would be a +3. That's like saying I'm subtracting 3, so now I'm going to add it. So if I add 3 on this side, the opposite function, then I got to do it on the opposite side. I'm going to add 3 over here. That allows me to cancel those out. I'm done with it on this side. It goes away. But now I got math over here. All right, so what I'm left with on the left is my n divided by 5 is greater than or equal to, and now I got to figure out what's going to go here. So this was the last video, our integers. I have a negative and I have a positive. I can't add them, so I know I'm going to have to set it up as a subtraction, which is 6. 9 minus 3 is 6. And then I look for the largest symbol. Well, the largest number has a symbol of negative. So I know that my answer is going to be a -6. So far we have n divided by 5 is greater than or equal to -6. So now I'm dividing by 5. Got to get rid of the 5 because I'm still getting this n by itself. How do I get rid of the dividing by 5? Well, the opposite of division is multiplication. So I'm going to multiply by 5 over here. That's my opposite function. Then I do it on the opposite side. So I'm going to have to do it over here as well and multiply by my 5. So what am I left with? I'm crossing that out because that cancels it out. That's why I do the opposite function first. Now I'm left with my n. And then I have my multiplication of integers over here. So I know my n is greater than or equal to something, but what is it greater than or equal to? So my multiplication of integers, I do the math, and then I look at my signs. So I do the math and I get 6 times 5, which is 30. They're opposite signs, one negative, one positive, so I know my answer is a -30. So my final answer then, after I've showed all of these steps to get my work for showing work, is that n is greater than or equal to -30. I'm not solving and telling you exactly what n is equal to, but I know that it is greater than or equal to -30. All right, so then we have this one over here. Same process, step by step. What am I doing first? Well, first thing that I'm doing is figuring out what has to be alone. What has to be alone is that r. Have to get r by itself. So then my first math that I do is going to be the constant, the number by itself. not touching the r. And there is a positive 5. Well, if I have a positive 5, how do I get rid of it? I'm going to use a negative 5. So that's the same thing as saying I'm adding 5, so I'm going to subtract 5, my opposite function. Then what do? Now I do it on the opposite side. This time it's going to be going over to the left. Still going to be subtraction. Once I subtract them, what do I get? Well, these cancel out, which is my goal, because once again, I got to get the r by itself. Then I'm just going to subtract. It's basic subtraction. So when I do that, I get 18. So I have 18 is less than 3 times r. Now what? Well, I still have my coefficient with my variable. So I'm multiplying by 3. What is the opposite of multiplication by 3? It's going to be dividing by 3. So if I do my opposite function and then do it on my opposite side, I'm also going to divide by 3. So what does that leave me with? Well, that cancels my 3's out. It gives me my r alone, which is once again my original goal, getting r by itself and then keeping my sign. So I know r is greater than what? Well, straightforward, 18 divided by 6. Excuse me, 18 divided by 3 is just 6. So that's my answer. I know 6 is less than r, or we could say r is greater than 6. So it's just applying everything that we've done over the past several lessons with algebra, opposite function on the opposite side. Integers are going to apply. So now you have your assignment. Look at what it's asking. So on the front, you have to just figure out, look from the words, what the inequality looks like over on the side. You're going to write the number from the words over on the line. And then, if I remember correctly, there's 6 inequalities that you have to solve for. Remember to follow the steps using your integers, doing your opposite function on the opposite side, and you'll get the right answer. The next lesson is understanding this and applying it by then graphing on a number line our inequality. So as you work through it, if you have any questions, come and ask.